to What Is It About the Weather? Where once a week we get together and explore the many ways that weather finds itself projected into the stories of our lives. This week we're going to be talking about how plants ride out the weather. But as always, I like to take a few moments, right, early in the podcast, and say thank you to all of you who are taking time to support the podcast. Some of you do it by throwing some shackles at the old Patreon. Some of you do it by telling somebody else through your megaphone. Hear all about it and how to hear all about it. Some of you get your printing press out, print up flyers, spread them out in your local community. Okay, that's not exactly how any of you are doing it, but you get the idea. Whether you're in touch, whether you're pushing out, whether you're supporting financially, whatever method you're employing, one or all of the above, it is appreciated and helps us keep moving along with the podcast. You can learn more about supporting the podcast at whatisitabouttheweather.com/support. You know, I've got this construction site going on near me, and you guys in recent episodes, I know from time to time you'll probably hear that noise that drives me crazy, that truck backing up noise. I really think that, you know, if I had to invent some new technology right now, it would be related to how that thing only turns on if there's people in the vicinity that need to be warned. Because that noise drives me nuts. Drives me absolutely nuts. And it seems to find me near and far. But one of the other things that I've been intrigued about has been watching this construction. It's interesting. So my setup, I have a deck, a parking deck next to the building I live in. And that deck has a nice vantage point. So I'll go out there every so often and kind of look at what they're up to, see why I have a brown river running down the street in front of me when it rains, etc. But just to kind of keep up with it. And there's been a lot of construction around me. There's this big new corporate thing going on not too far away for State Farm and some other stuff. In any case, one of the things, you know, in following it, I kind of watch how do they manage, because there was one across the street a few years ago that had this big spring flood, and it seemed like they were constantly delayed in getting started because of the rain. And I think they were. But I should probably really do an episode on construction and podcasting. But one of the other things I'm intrigued about specifically with it are the cranes. You know, the big things where somebody's sitting up in that little control booth and I don't know. I've seen some winds blowing around and some lightning storms come awfully close to that. And I'm curious what the guidelines are, because there have to be some. My speculation is it's kind of grounded. My speculation is it's also kind of neat. In some ways, it's kind of neat. Although I got to imagine in a strong windstorm, probably even more so than the lightning storm. Again, I'm hoping it's a grounded little container that they sit in. But man, that thing's got to get rocking a little bit when it's windy. I know they're stabilized and everything, but we've seen episodes, you know, across the globe where these things have gotten blown over or pulled off buildings. But I don't know, you know, a lot of times they're attached ultimately to part of the building as the building continues to go up. Or maybe they're even at least a little sheltered by the building. But in the early stages when they put that full thing up there and it's completely exposed, I often wonder what the wind sensitivities are with that. I don't know. Maybe a future episode. We'll see. We'll see. And even as I say that, I hear one of those silly vehicles backing up. Sorry about all that. Sorry. Hope not too much of it gets into the middle of the podcast. I know they do, because I hear it from time to time when I listen. You guys probably wonder that. You know, I've told you before that I don't particularly do edits with the episode. Now, if I have a big goof up, I may clip out a little bit. And I'm more inclined to restart in the beginning. Like if I didn't like the first minute, I'll just delete it. But generally speaking, I don't take out that kind of noise that goes in from time to time. But I do hear it, and it just seems like part of life. So I generally leave them in there. But again, thanks for pushing through. Hopefully they'll be done soon without it being too much longer. They're getting close. They're getting close. They finally paved the road around the site, so the trucks don't sit so close to me and just idle and make as much noise. But enough about all these man-made structures. Let's talk about plants. You know, we did this cheating weather, beating weather episodes a few back. And in the context of those conversations, we've talked about agriculture a little bit as well. The last episode, these microclimates. Thought I'd do one more about plants. And then we'll put plants away for a little while. Because I find it intriguing. You know, in those things, we talk a lot about items that we can control. And in the things that we do, we have this luxury, right? When we want to get out of the sun or out of the rain or away from a dangerous storm, we can move. Animals can move. Plants, not so much. Okay, I know I mentioned tumbleweeds not too long ago as well, briefly. I know there are plants like tumbleweeds. And I know that some plants have that flexibility. But generally speaking, what if you really couldn't move, right? What if you really couldn't pick yourself up and go from one location to another? How would you deal with it weather-wise? And no, I'm not talking the simple things like being able to turn yourself around. And I know a lot of plants adapt that way. You know, maybe turn a flower face towards the sun. But what if you could? What would you do? You know, one of the things that you'd have to do is figure out how to survive, right? When it gets hot, when it gets cold, when it's too wet, when it's too dry. What would you do? Well, plants are kind of interesting in that they've adapted over time or have these abilities built into them that give them some technology, if you will, that we've actually learned to use in other ways. But, you know, maybe the first case we think about so often is the cold part. And I say that for somebody who lives in the mid-latitudes who has seasonality. But, you know, so many plants go dormant in the wintertime. Well, some stay around year-round, but many of them go dormant. They lose their vegetation. They adapt. And it's interesting how they even do that. And like I said, some of them don't. Some of them evergreens just stay around all year. So how do they do it? How is it possible that they do that? Well, you know, like a lot of things, plants like water, kind of like most animals do. We make use of water, right? Well, they're smart enough to turn their water in their cells into a little setup that's essentially like antifreeze. They use sugar or sugars to change the freezing point of water and their cellular structure. Now, on the flip side of that, some others just completely drain it out, you know, let their foliage fall off, go hang out in the base down below the freezing line, hopefully. And the hardened part of the plant kind of has a thermal barrier. But what they're really trying to do, and it's interesting, in the show notes, if you're really into this stuff, I put some stuff in the show notes that you may find intriguing. Some's a little more sophisticated, some's a little less. Some's an easy read, some's a little research. But it gives you a sense that one of the challenges that plants have, much like humans, is you don't want air in your veins. Little air bubbles you can deal with, but the big ones can create some dangerous stuff. And so what they're trying to do with this drainage is avoid that. And then they start pumping stuff back in when air is less likely to be introduced once it starts warming up. where you run into problems, and maybe you've seen this before. Maybe you pruned a plant the wrong time of the year and you stressed it in a certain way. But what we come to know is the plants tend to survive. Yeah, you can get really cold. You can get too cold and kill off plants, even hardy winter type plants. But usually where you run into dangers is when the plants change in and out of seasons too quick. And this could be going into their dormant season, or this could be coming out of their dormant season. Or maybe they don't get the triggers right? Maybe it's supposed to be fall. It's supposed to really cool off, and maybe the fall doesn't come around and prompt them the way it would. And, this happens a couple ways, right? Days get shorter. That generally means some cooler nights. They kind of get the hint, right? So it's not just about the temperature. It's about the plant's recognition of how long a day is and recognizing that it's getting longer or shorter. But if the hints are too subtle, like if those time of day issues aren't combined with the changing temperatures, it can throw them off. And then all of a sudden they get one of these fast changes on top of it, and it can be lethal. But again, they employ techniques we use. Insulation, creating that antifreeze is a natural antifreeze. That's kind of neat. Or just, kind of giving up part of the plant. Moving out of the summer home, if you will, the canopy at the top of the tree. And move into the winter home with a little heat. Take advantage of the heat of the earth. Now, what about the flip side of that, right? What about when it's too hot? The visual representation for us then, again, is quite often it's a foliage thing, right? We see some plants that maybe are flowering plants that'll stop producing flowers. Maybe they'll even produce smaller leaves. But some plants have adapted with what are called heat shock proteins, all right? And plants have, it's like anything. You cook when you get hot, right? And the plants are the same thing. So what these heat shock proteins do is it allows the plant to essentially not be overheated. So it's like a coolant. So, you think about any vehicle, you use an antifreeze coolant, the whole idea is to keep things in a range. And plants adapt on the other side, very similarly. They work in a way that tries to keep them from getting too cold or too hot. And those heat shock proteins keep other chemical processes from occurring that would cause them to overheat. Oh, it's just kind of interesting. It's this, with a lot of things, adaptations that we see in the natural world that we've reproduced in things that we do. So how about when it's too dry, right? Now, we all know that plants use carbon dioxide, right? But they also use oxygen. But the tricky part is CO2 they typically get through processes that they essentially open their cells, if you will, to take in the CO2, but that usually means water has to escape. So it's this delicate balance of getting enough CO2 while preserving the water. Some plants are better about it than others. And classic example is a cactus, right? And what they do is they do nighttime parties. They wait to do their opening until the nighttime and pull in the CO2 at night. But they're built as such that they can store the CO2, which they need for photosynthesis, until the daytime when the sun's out again, and then use it as part of their process. A lot of plants just don't have that capability. But cacti are also smart in the way they grow. Some people think a lot of plants do deep root systems, but cacti tend to have these very broad surface-based systems, such that when it does rain, because they're likely in an area that the water will drain quickly, they can get as much of it as possible, absorb it all up, and hold on to it. And then over time, they'll sacrifice parts of that root system, if it gets really too dry, to keep what has stuff. But another thing that we've learned, and there is a research paper, I think I put this one in the show notes. Maybe I did, maybe I didn't. If I didn't and you want it, let me know. That maybe it's about the salt. And apparently the saltier the genetic makeup of a plant, the harder it's going to be for handling drought. So again, very basic things. And it's things you think about in your kitchen even. You know, we have sugars. We have these proteins that keep the plant essentially from becoming cooked like oil. We have salt. And we all, have probably heard this at some time. This is why oceans don't necessarily freeze when they're below zero. But salt does a lot of other things, right? It makes you retain water. So it seems kind of logical that that's what would be going on. But recent research has confirmed that that is indeed the case. Speaking of water, what do they do when they get too much water? Holy schmolies. I mean, this is the one that always throws me off because let's be clear. Anybody that's ever grown plants, one of the things that people tend to do more of compared to underwatering is actually overwatering. And that can be detrimental to a plant. Because what you got to keep in mind with most plants is not only do they absorb water through the roots, but they get everything generally through their root system. Not the CO2, okay, we talked about that. But other nutrients, they tend to get that stuff, including oxygen. Plants use oxygen through their root system. So if the root system is constantly in water, it can't get these other things. Essentially, it drowns. And this is why they always tell, it's that balance, right? You don't want to have to water plants every day if you have plants. But this is why they need good drainage, because not only do they need to get that water through the root system, they've got to get all these other things that they pull from the soil in which they're in. But there are examples of plants, and actually the one that probably hit me the most, or the first thing that I thought about, was like a rice paddy. These plants sit in water for an extended period of time. And what they've learned to do is they've learned to breathe with the part that's above the water line. But even other styles of adaptation have taken place, like a mangrove swamp. What they've learned to do is some of their roots, the actual roots, grow upward and create kind of a snorkel to where they can get above the water. Or, aquatic plants in ponds. What these systems have learned to do is absorb other ways. To put a little bit, maybe for a period of time they can handle nothing being above water, but eventually they've got to get something above water that allows them to take in these other components. And their system is different such that the plant itself can funnel these things still down to the root system quite often, because the roots is still kind of where all this, digestion, if you will, if you think about it in an animal sense, takes place. So it still has to get there. It just gets there a little different way. And I find that interesting because, we think about moving when temperatures change. And again, that could just be like in the summertime going indoors. And it's coming fast and furious for me. And before you know it, I'm not going to want to be outdoors. I think I'm going to hibernate for the summer or something. But you get all these things, and we have the luxury, if you will, of being able to get out of the sun. Hopefully, you've got a place you can go to, or out of the heat, or out of the elements. But plants have had to learn to behave differently and use different aspects of nature to give them the ability to survive. But they do. Now, that's not to say that if you pick up plant A and put it in plant B zone, and this is why you see these different zones, that it's going to survive. It knows how to function within its space. And a lot of times as plants because plants migrate too, right? As plants have migrated around the globe over time, they've had to create these adaptations. But it might be why it tends to happen more slowly or over time, so that they can figure out the proper way and the best way to do it. And I came across, there was an interesting website that I came across in doing the research on this called How Plants Work. It's a blog. Doesn't seem maybe he's as active as he used to, although, once a month it seems like he still posts stuff. Very interesting. So if you find this topic interesting, a couple of the links in the show notes will go to that site, but just howplantswork.com. You might find it interesting. One of the things I found in there talked about how plants actually change the weather versus the weather changing the plants. It was an interesting story about the role of vegetation in the broader weather system. And, you folks who like this podcast may find that sort of interesting, so check it out. Definitely check it out. We've talked a lot about plants, and so I'm going to get off the plant cycle, if you will. It's just been sort of intriguing. It's that time of year where I'm seeing it, and I thought I would do this. Well, this one had been on the list for a while, so I think I'll put plants down. We've probably had enough plants. However, as always, if you got an idea about a plant episode or thoughts about this one, don't hesitate to reach out. What is it about the weather at gmail.com? What is it about the weather.com/contact? I just heard some other beeps probably got in the podcast. That was my phone. That wasn't any beeps from a construction site. Any case, as you're out looking at the plants around you, taking care of some in your yard or your garden, or just in a house plant, whatever it might be, or you're out looking at some big open area and you wonder how they do it. Well, they're probably employing some pretty neat technology to deal with the weather environment they're in. But learn a little bit about it. You travel somewhere, learn a little bit about the local flora. Maybe do some investigation to how they survive extreme conditions. Because plants are out there just like us, dealing with the weather every single day. So whatever it might be, learn a little bit about weather and plants. Just about weather and everything in general. Because as we all know, there's much more to weather than the weather itself.
This is WIIATWEP097 production.
We're tired of hearing our uncle grovel, so please support him on patreon.com/weather.